welcome to today's class. It is the 26th of May and this is class number 93. So what we're going to look at today is solving inequalities. So we are well used to solving equations. Now we're going to look at solving inequality. When we talk about an equation, we talk about balance because they are equal. Now in an inequality, we don't necessarily have that balance. However, our scales are just slightly tipped. So here's an example of 10 is greater than 8. So would the scales say the same if the same amount is added to both sides? Yes. If the same amount is subtracted from both sides? Yes. The mass on each side is doubled, multiplied? Yeah. Or the mass on each side is halved? Yeah. So actually, this idea of the vertical balancing, that idea of balancing, it stays true for inequalities even though we don't necessarily have a balance to begin with. The reason for that is because if the scales are off balance, keeping the same thing happening to both sides will keep that off balance the same the whole way through. Now, here's some examples numerically. So 6 is greater than 4, add 4 to both sides, 10 is greater than 8. That's true. Subtract 3 from both sides, 3 is greater than 1. True. Multiply both sides by 3, 18 is greater than 12. True. Divide both sides by 2, 3 is greater than 2. Yeah, true. Multiply both sides by minus 2. So then we get minus 12 is greater than minus 8, which is actually false. Because if you think about temperature, minus 12 is much lower, it's smaller than minus 8. So actually, we found a little bit of a blimp for when we're working with inequalities. But this can be generalized as we solve an inequality just like we solve an equation with one exception. And that exception is change the sign, change the inequality. I am going to show you the one step that you can do to make sure that you know when to work it, and then we can do multiplication and division. So the rule is going to be if I change the signs, I change the inequality. So let's take a look at an example. One big difference between solving these inequalities versus solving the equations is with the inequalities, we tend to be asked then to plot our answer on a number line. So because we need to plot that on the number line, they do give us this extra piece of information, which I'm going to box because it's not part of the inequality itself, but it's telling us that our answer is a real number. So remember, the real numbers are all numbers. So now we're going to focus on the inequality. I'm going to do vertical balancing here. You can do any kind of balancing. It doesn't have to be vertical. If you've gotten the habit of like subtracting 7 from both sides, that's perfect. But I'm going to take away a 7 from both sides. So effectively what we do if that was an equals. I then have 2x. This goes to 0, which I ignore. Then I have a less than or equal to, and then I have a 4. To finish it off, we would divide by the coefficient of x, so the number in front of x, which is x is less than or equal to 2. So if I want to then plot that, it is a real number, so I'm going to bring that down here, where x is an element of the real numbers. So x is less than or equal to 2. So it is equal to 2, so I'm going to dot that. And then it's everything that's smaller than. Remember that this inequality sign acts like an arrow. So we're going to work all of the way here, and it's going to go on forever. So it's a continuous line because the real numbers are all the numbers. So we're doing so many dots to catch all those numbers that it's starting to look like a line. And it's very clear that we're including that too. So example 2. Here we're told that x is an element of z. That means it's an integer. Remember, integers are positive and negative whole numbers. So we are not dealing with all numbers on the number line, we're only dealing with whole numbers. Again, I'm going to focus in on my inequality and I'm going to do vertical balancing. So I'm going to add 2 to both sides. I have 5x is less than or equal to 10. To finish it, I'm going to divide both sides by the coefficient of x. So x is less than or equal to 2. This time it is an integer, so I'm including 2. And again, the inequality points me to the left. It's less than. all of these numbers to the left are included. And once you bring that down to the end of the number line where there's an arrow, it will continue on forever. So example 3, in this question, they've told us x is an element of n. So n is natural. So this is positive whole numbers. Just the positive whole numbers, and 0 is not included. So vertical balancing, I'm going to add 2 to both sides. And I get 3x is less than or equal to 12. Divide both sides by the coefficient of x. So x is less than or equal to 4. So 4 is included, so I'm going to dot that. Remember, because they're whole numbers, we're dotting the whole numbers. 3 is included, 2 is included, 1 is included, but then we stop because they've told us that it is a natural number, so we stop at 1. So the 4 numbers which are part of our answer, it's 1, 2, 3, and 4. If we were asked to give that answer as a set, we would say x is an element of 1, 2, 3, or 4. So that's the second way, or it could be less than or equal to 4, where x is an element of n. So there are 2 different ways of displaying the same information. So if they actually wanted it as a set, we have that second method, but it's much more common to ask for it on a number line. So example 4, our final example, we're going to solve this inequality where x is an element of or. So we're going to do our vertical balancing. Here I'm going to take away a 1 from both sides. And when we do that, we get minus 5x is greater than minus 15. Now, this I've picked on purpose for you to show you that one time where the inequality doesn't act like an equals. Now, we can talk about multiplication and division, but I find that that's very hard to remember. So, if we have a case where the coefficient of our letter, in this case our x, is negative, we're going to do something, and that is we're going to change the sign, the signs, plural, S-I-G-N-S, and when we change the signs, that will also change the inequality. So we're not going to do anything else. We're not going to really do any division or multiplication. We're simply going to change it. So the minus 5x becomes 5x. The minus 15 becomes a positive 15. But the greater than symbol becomes a less than symbol. So that has now corrected that negative. So this is, instead of remembering, oh, when I multiply by a negative number, when I divide by a negative number, we just are going to do, when I see a negative coefficient of my variable, in this case x, I'm going to change the signs, and that in turn changes the inequality. And I will write this out, and the leaving certs will tell you, I write this still beside their work when they're doing it. Because now what I have is I have a much simpler sum I can work with, and I'm going to divide both sides by the coefficient, not worry about anything, and I have x is less than 3, remembering that x is an element of or, so real number. Now, real numbers are all of our numbers, which means I want to make sure that the whole line is highlighted, because there's so many dots it starts to look like a complete line. Now, I do not want to include 3. So what we do when it's a real number is we do this empty circle. That is only when it's a real number, because if it is an integer or if it's a natural number, we just skip that number because we're only dealing with whole numbers. So now what we have is we have all of the numbers up to but not including 3. So it's a very obvious open circle and then our arrows. So just take all that into account.